Let's explore the various media computation functions we have available to us to work with color. First, let's remember that the smallest accessible piece of a picture is referred to as a pixel. It derives that name from a picture element, an element of a picture. Picture was shortened to just pix, and then L from the element, and the combination of those becomes pixel. Each individual pixel has a red, green, and blue value, and it's the combination of those three colors and how much of each color will determine the color that we see. Each of those components, the red component, the green component, the blue component, numerically has a value that ranges from 0 to 255. And that limit is established because it's stored in 8 bits. 255 is the largest integer that can be represented in 8 bits, 0 being the smallest. So it's a range of 0 through 255. And that's stored in 1 byte per color component. So to represent the entire pixel, all 3 color components, we require 3 bytes or 24 bits. And the thing that confuses most of us as we start learning about how color works with light as opposed to pigment or paint, for instance, we've probably learned in grade school that if I take yellow paint and blue paint and mix them together, I get green. You kind of have to ignore everything you learned about mixing paint, because light mixes in a different way. While pigment or paint is scientifically referred to as a subtractive process of mixing, light is actually an additive process. And so you see over to the side of the screen, there's a rainbow of colors there. But imagine that we've got 3 different spotlights, one that's projecting green, one projecting red, one projecting blue. And so you can see those 3 colors on the outside edges. But notice in the very center, where all 3 of them are overlapping, we actually end up with white. If we just look at the combination of green and red, we get yellow. Combination of red and blue, we get purple, which is one that does match up favorably with the paint, but that's kind of the only one. And the combination of green and blue at that intensity results in cyan. The total absence of all of those colors is black. So full value of all of them is white, 0 value of all of them is black, and the various combinations in between produce the variety of colors that we can make use of. So let's look at the various media computation functions that we have available to us to work with color. The first is that we can, given an individual pixel, if we have previously in our program stored a pixel into a variable called pixel, it could be anything, I'm just using that as an example, we have a getColor function where we can inquire as to what the color of the pixel is. An example of that in code might be that we would say color equal getColor parenthesis pixel parenthesis. Again, pixel is representing a variable that contains a pixel, and then color, the variable on the left-hand side of this equal sign, would receive that value as a red, green, blue value, but it would be stored as a combination of a color. We can also get the individual color components. So if all we want to do is know what the red value of a particular pixel is, we can use getRed, or green, or blue. We've got a function for each one of those. Again, we have to tell it what pixel we want the color component of, but we provide the pixel, and it's going to give us back that component. So an example of code, we might write something like red value equal getRed of pixel. Again, pixel being previously defined. We can change the color of individual pixels. If we want to change all of the color components to, that is to say, the color of an individual pixel to some color, we can use the setColor function. An example use might be setColor, and we have to give it 2 things. We have to tell it what pixel we want to change, and we have to tell it what color we want to change that pixel to. So my example is that we were changing the color of the pixel to cyan. We can also change individual color components of a pixel. So we have setRed, setGreen, and setBlue. Again, two pieces of data we have to pass to those functions. We have to tell it what pixel and the color value. Again, remember the values of a color component range from 0 to 255. So my example on this one is that I'm setting the red component of this pixel to the value 127, which would be a roughly middle value for the red. Before we move on, notice that the get functions, the getColor, getRed, getGreen, getBlue, as I've used them in example code, I've assigned them to a variable, and that's because those functions give us data back. We give it a pixel, it gives us a value back relating to what we're asking for. Notice in my uses of the set functions, the setColor, setRed, setGreen, setBlue, I have not assigned that to a variable. And that's because these functions don't give us anything back. They take an action. If you remember earlier in the semester, we talked about something called a side effect. These set functions are an example of that. We're giving them a pixel and giving them a value for that particular function, but they're not returning anything to us. They're not giving us anything back. They're taking an action. They're setting the color or setting the color component value. So something is happening, but it's not actually returning a value, so we don't assign them to a variable. And then a couple more functions that we have at our disposal. One is a function pickAColor, and this actually causes the dialog box I've shown in the top right of the screen to pop up, where the user can mouse and choose the colors, or in the bottom right you can actually type in values for the red, green, and blue that you might want, and it will return then the color that has been selected. And so again, this is an assignment that we're making. The example is color equal pickAColor. Notice we don't put anything inside the parentheses of the pickAColor function. We're not giving it anything. We're just asking for it to display the dialog box. The user will make a selection, and then it returns the values that the user selected. And the last function we're looking at today is makeColor. So here we can actually give this function three color values, the three components, the red component, green component, blue component, in that sequence. It's always red, green, blue. We give it the three numeric values we want, saying how much red we want, how much green, how much blue, and it will return a color that matches those three components. In this example of code, I'm saying color equal, because it's going to give me back a color, makeColor 127, 142, 255. So I'm saying I want middle red, I want a little bit more green than middle, and I want full blue. And if you look in the numbers up here in the example of the pickAColor box, those are actually the numbers I've typed in. So what I would get back is the color that represents this, sort of a light purplish blue shade. And that would be stored as digital data in the color variable, and then I could use that to set something else to that color. So we've got ways to get the color from a pixel or get the color components. We have a way of changing the color of a pixel or the individual color components of a pixel. And we have ways of picking a color as the program runs, and then also making a color based on the values that we calculate. We'll see you in class.